Okay, welcome. Welcome to my first attempt. This is Planet Geography and our first ever video. So I thought what we'd try and tackle today is the formation of a cyclone. So what I've decided to do is to kind of break it down into three stages. So the formation, which will cover location and conditions required. Then development, how does it turn from a kind of an area of low pressure into a fully fledged tropical storm, and then kind of how does it finish by breaking up and going back from a tropical storm back into an area of low pressure. In this case, we'll call it dispersation. So let's talk about the requirements for formation. So the first thing we need, and the most important thing, is of course, this whole process comes from the sun. The sun emits shortwave radiation, travels through Earth, and then it is absorbed by our oceans. So, first thing to note here is that our tropical cyclones are seasonal. They take place during autumn, and this comes from the fact that obviously the season before autumn is summer, so they're being heated the whole summer. And slowly that temperature is rising and rising and rising until it reaches that really significant number that you need to know for this process, called 26.5 degrees. This is the deadly number that we need to know. This is the number in which we're moving from an area of low pressure into an actual tropical storm. The other thing you need to know in terms of the formation is that we need, at this point, calm conditions and low winds, so it doesn't break up the hurricane or cyclone or tropical storm. We also need to know that this happens in the tropics. So the tropics being between the Tropic of Cancer and the Tropic of Capricorn, so basically along the equator, okay? That happens because this is where the concentration of solar radiation is highest and can get that number up to 26.5 degrees. So if you've lived in England, you've probably never experienced a tropical cyclone because the oceans surrounding England have never got anywhere close to that temperature. So that is formation done. 26.5 degrees of ocean temperature and in the tropics. So let's talk about the development. So what happens at 26.5 degrees, you start to get a really significant amount of evaporation, okay? This causes the air to rise. So we start to have an area of low pressure forming, okay? Like so. As we know, steam, hot air, it travels upwards. Now, as it travels upwards, it starts to do the opposite of evaporation, which I hope you know, is condensation. So let me draw this again, the sun's gonna get in the way. Yeah, condensation forms precipitation. So cyclones are kind of sadistic, meaning kind of evil. They'll kill you in lots of different ways. And one way is intense precipitation. Yeah, so condensation is also the opposite of evaporation. It's an exothermic reaction, meaning that it releases more energy the more condensation that takes place. So not only does it give us the intense precipitation that causes flooding and even mudslides or landslides, it also adds more and more energy. And this happens in a kind of cycle effect of more energy being added, leading to the whole process to speed up. And so let's complete our diagram like so. What we also see at this point is the eye forms. So as the air begins to sink, because again we know that cool air sinks, we see that when we open a freezer, the air begins to sink. We see air sinking. This causes an area of high pressure. So at the center of this huge area of low pressure, we have an area of high pressure. So high pressure causes the complete opposite conditions that we expect for a hurricane, right? So it's clear skies and low winds. And this is what gives the cyclone its classic eye formation at the center. I'm sure you've all seen pictures. What we see here is that around it, I should be doing this the other way, really. Around it, the air is spinning around the eye. We call this the Coriolis effect. So what I'll do is I'll flash up these key terms, because you really do need key terms to be able to explain this process, all right? Those tier 3 geography terms. I'll flash them up on overlaid the video. So we have the Coriolis effect where it's spinning, and it's spinning around the eye wall. The eye wall is the most intense area of the cyclone, the highest winds and highest precipitation, okay? So we've got the Coriolis effect, we have rising air, we have falling air, we have high pressure, we have low pressure, we have evaporation, and we have condensation. Again, we're kind of getting to the key bits of this. Things to say at this point: because so much air is rising through this kind of form of evaporation, we can't have a vacuum being created, right? You should know that from science. We don't want an atmospheric vacuum. So what happens? Well, huge amounts of wind start to get sucked in, okay? To fill that void, to fill the vacuum. You know, the strongest winds ever recorded in a tropical cyclone are 300 kilometers per hour. They recorded in the Philippines. I mean, that is just flattening buildings at this point, okay? And it's all doing that because there's sheer intensity of the evaporation that's taking place to feed this, okay? Remember, this is all coming from the 26.5 degrees. So, again, there's the other kind of the second way that cyclones can kill you is intense precipitation, one, and then number two, there's huge winds that can come, they'll knock over trees, knock over buildings and crush you. All right, the next thing that we need to know is storm surges. Because there is so much evaporation, the pressure is being taken off of the surface of the ocean. So there's less weight of air pushing down on it, there's more pressure, there's less pressure involved. So again, if you're pushing down on something and then suddenly you take away that pressure, what's it going to do? Well, it's going to rise up. Its volume is going to increase, if we're going to use a technical language. So that's exactly what happens. The sea level temporarily rises, and we call this a storm surge. This is potentially the one that kills the most people, actually, particularly in coastal areas. So we're kind of getting there now. So we've got the kind of main way that cyclones will kill you, how they're formed. This is a cumulonimbus cloud, okay? It's actually a lot easier to spell than it is to say, all right? So again, I'll flash it up, overlaid onto the video. It's a cumulonimbus cloud. These can be kind of 15 kilometers tall. So if you're from London, you know the Shard, you're talking about 30 shards stacked on top of each other. That's how tall this cloud is. And again, in terms of the width of it, the largest ever recorded was 2,200 kilometers. That is the distance from London to Istanbul. Okay, it's about a 4-hour flight. So this is how it develops. That kind of process kind of becomes stronger and stronger and stronger. So we have the formation, we have the development, and then let's kind of end the story. So basically what happens is that our cyclones will make land. Generally, in the north of the equator, they head northwards, and south of the equator, they head southwards. If you know what diffusion is, it's very much linked to that. There's a high concentration of energy at the equator and a low concentration of energy at the poles, and all the Earth is trying to do is balance that, almost to try and reach room temperature. So cyclones are very predictable in their track or their paths, is they will, in the northern hemisphere, always kind of hook upwards, hook north, and that's what's happened. In this one, as they travel, as they travel inland, they get to make land, the storm surge will follow. So the storm surge will follow, and as a result, we'll see an elevated sea level on our coastlines, linked to the huge waves that we would expect. Again, you should know from the coast that the friction from the wind causes the huge waves. Again, so we experience huge waves and an incredibly high tide, and suddenly, dear oh dear, this person's in trouble, okay? It really is something to keep an eye on, is the storm surge, okay? So, what happens as our hurricane moves over land. So, kind of moving it along, drawing a very quick hurricane over here. Our hurricane's now over land. But what we notice is that because it's over land, you've got to think about the causes. Okay, it's cut off, over land, it's cut off from its energy source. The fuel for this whole reaction, this whole literally chemical reaction, is coming from 26.5 degrees ocean surface temperature. Once it's over land, there's no evaporation. So I use the metaphor of a car on a motorway that's run out of fuel. It doesn't screech to a stop, it slowly rolls to a stop, and that's exactly what happens. It disperses. Again, I'll flash it up. It disperses. This is when the eye kind of collapses and it turns from a cyclone or tropical storm. It kind of collapses into just an area of low pressure, which we know as a rainy day kind of thing. The other way it can kind of lose energy and disperse is when it travels over an ocean that's temperature is no longer 26.5 degrees. So if it's in the middle of the Atlantic or the middle of the Pacific and it hooks northwards, it's going to go over oceans that aren't as cold, aren't as warm, that are colder. So oceans that are 20 degrees, 15 degrees, 10 degrees. And again, when it does that, it just does not have the energy to maintain itself. And so it kind of collapses in on itself, the eye collapses, and we just break up to. So if you do live in England, you are regularly hit by the remnants and remains of dispersed hurricanes. And we just know them as really rainy days. But yeah, it's exactly what happens. So this is a very whirlwind tour to the formation of a hurricane. Okay, and if we go... Okay, so let's tackle a question from the Geography B Edexcel paper. Again, it should be really relevant if you're doing AQA or Edexcel A, as it's a geographical process and it's exam technique. So, here is our question. Again, pause the video if you're familiar with the channel and bug it. Box the command word, underline the keywords, and glance at the marks. What would you do if this was the question in the exam? If you're not, we'll proceed, and I'll show you how I would do it. So, B, box the command word, explain. 2, I'd underline. Reason, cyclone, lose energy. So really, if we kind of condense it, why do they lose energy? Why do cyclones lose energy? And then we glance at the marks, it's a 4 marker, and we see here it's 2. So it's going to be one reason is because. Another reason is because. Okay? And here we see our mark scheme, and we see that they really feel that there are 3 responses. You know, we can do another response, but there is the big 3. For me, if you pause this mark scheme and look at this, number 3 is, for me, something you could write about. We did mention it about the low wind speeds, but these are the big 2. I think 95% of candidates will write about these 2. So pause and have a look. But we see, yeah, when they reach land and when they move over cooler oceans. Okay? So that's how we're going to proceed. So let's have a look. So one blank is, one reason is because, another reason is because. So here we go. One reason is when storms reach land. That's going to gain me a mark because they no longer have access to evaporation from warm ocean waters. Okay? I've got that word evaporation in there, warm ocean waters, definitely enough for the 2nd mark. Now, next point. Another reason is when they travel over cooler oceans. Okay? Again, that's going to be a mark. Because as they move away from the equator, ocean temperatures drop below 26.5 degrees. Now, again, I'm getting the mark for 26.5 degrees and equator, probably. I was tempted to talk about evaporation, but I don't want to be kind of repeating myself, so I had to kind of think of a different way that wasn't evaporation to get that 2nd mark, okay? And really, talking about moving away from the equator and below 26.5 degrees does that, okay? So be careful of repetition, as examiners won't award marks for that. I think that gets 100%. I don't know if you agree. But yeah, I hope you found it useful. Like and subscribe for future videos. We'll be doing more on exam technique and geographical processes. So join.